Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Oh, hi, ladies and gentlemen. Welcome to another tutorial. This time we are going to discuss Docker orchestration. Docker orchestration is a very important topic in the series of Docker because it solves some existing problems. So conceptually, to understand this is very important that we first understand that what is the need of that. So to walk you through the need of this thing, we first need to go through the application architecture. There are, in principle, two major kind of application architecture, right? One is the monolithic style of application, and second is the microservice. So these are the two major kind of uh, application type. This is, for example, monolithic application and monolithic, and this is microservices. So in the start of, for example, in start actually, what happened is that people tend to have one virtual machine. For example, this is a virtual machine run on the virtualization layer, and they have all the part of the application in one virtual machine or one big server. Maybe this is 50 GB of RAM and then 50 core of CPU. This is a big virtual machine here. Based on the virtualization layer, there are some small operating system, virtualized operating system. For example, here one, here two, and this is the operating system number three. And then, for example, they need to, or they tend to write, deploy this small part of application on this one stuff. So, for example, we can say that we always take the example of insurance company that in insurance is health insurance, private health insurance, provident provident funds, PVHI. So for example, we just can give them a name PVHI, provident PF, or car insurance CI. And then, for example, there is another part, legal insurance LI. So there are different business of one in insurance business that they are offering the health insurance as well as a uh, part of service. And then there is a provident fund for the people who want to get retired and want to get some insurance on top, and then car insurance or the car insurance, and then legal insurance, for example. Now there are different subsequent parts. So here we can say that, here is, for example, HI, all the services related to the HI, also running Provident Fund here, then CI, and then legal insurance is running in this virtual machine. They are typically a complete virtual machine based on the virtualization layer, and this is something like similar to that. You have VirtualBox, and on top they are sharing the resources from here. This is hardware resources, but they create this, and what happened is that every service is interconnected with each other somehow, and as a one go, they are offering some services, right? Now, this is the one style of application which is in the previous, like 1 decade before or 20 years ago. The major problem with such kind of service is that if this VM actually for some reason is gone or destroyed, whole these application time is down. And for example, if I need to replace this virtual machines for some reason, I need to shut down whole actually service, and then due to the maintenance activity might be in the 10 years ago or 20 years ago, you have heard that, okay, due to maintenance activity over services down, these messages are, sometimes very often you see. But over the passage of time, when people get smarter, when technologies get smarter, containerization and or orchestration, there are a lot more advancement come into the market. And now all the applications are meant to first run 24/7. Second thing is that what people do, that people create the container of them. So for example, this is service number one, this is service number two, service number three, and service number four. And they just run on separate container. For example, this is the health insurance, this is the provident fund, this is the car insurance, and this is the legal insurance, for example, let's say like that. So these are the four different paths in microservices. They are just complete separate containerized environment where you can give the domain name server to this to app dot, for example, let me just write here app.hi.com. Here I can write pf dot app.pf.com, or here I can say that app.li.com. So nowadays, all these services are completely separated and they are in containerized environment. This is the thing number one. And the second benefit of that is a very beautiful benefit, which is that they have layer of container. This is not a single container, but this is again multiple containers here, right? So that's not just single container, but there are multiple container. So there are in total, for example, in redundant, every container has three extra duplicates. These are the duplicates, dupli, duplicates. So these duplicates are so efficiently organized that if this container is destroyed or gone, it's automatically get replaced by the other. Now, if this service is gone, at least their two services are still running and give you a seamless operation. And similarly here to every system has 3 copy, 4 copy is normal practice. So that calls the backup or redundancy or load balancing as well. So there are multiple benefit of that. So nowadays microservices, there's no single point of failure, no single point of failure. Then automatic load balancing, automatic scaling. There is a difference between load balancing and scaling actually. And then auto healing concept. And then there are, independent blocks of microservices. So these benefits are really marvelous because at least if you're going to do this, and what people do is that, for example, they always have different, different environment. For example, then you could get the copies of, let me just draw another copy. So then you create one copy of this whole environment and you call it dev environment. And then you create another whole copy and another complete copy of this environment. or the duplicate of this copy, and then you can call it prod environment or pre-prod, and then there is always a final copy, which is something like that. This is always a final copy here, and this is broad, broad environment. So yeah, nowadays, and this is the style of the application, which is, very beautiful. It is very cool, and everything looks good and very beautiful. So now the thing is that where the Docker Compose or the Docker orchestration come into the picture. Now, if you see here, I have three cores are 12 container in the each environment, and in total I have this is only for three kind of sources. So if you can see here that I have to manage 36 container in total, and 36 container in total. So it is very inefficient that I go here and I first create a container number 1, 2, 3, and if I need to load balance them or change them, and a slight configuration change in the one Docker file. Well, I have that Docker file for sure, which is instructional written, but I have to perform Docker run 36 times, let's say like that, or these kind of stuff. So now, similar to the Jenkins and similar to the Ansible, we have seen that when you have server of three environment and 100 computers, you need to manage them somehow. And you cannot go and do configuration. That's why you use Ansible. And similar for the Docker. When the Docker complexity get bigger, then you cannot go there and you can just, create everything by manually. So to mitigate this problem, there are different solutions in the market. Docker Compose, our old solution for less complex issues and not widely used right now. So this is the Docker Compose. So this is the one thing. But for the very small stuff, for example, if I have 5 to 10 computer and I want to manage it, then it's maybe okay. But over the passage of time, when I can say that, for example, for every three services, this services is again divided into some subparts because the health insurance is the big thing. And within the health insurance, you can have three regions. So you're offering in three different multiple regions, and for every region, for example, you have for example here app.hi.de, app.hi.en in the app.hi.eu, and different multiple region. So, for example, every health insurance app is divided into different business. When you go for the higher corporate level stuff, then the things are getting complex. And now you have added the simple layer by the three, and now you have rather than 12, you have here 24, and with 24, you know, mm, you have 72 computer in general here. Let's say like that, and the complexity has gone bigger here, for example. So you have another layer, and the second layer you have 72 computer in general, or Docker container in general. So the this old solution is not gonna work. So what you can do is that you need to come up with the idea that which is Docker Swarm. Swarm means that when there's a multiple flying insect or multiple flying birds fly together. So like bats, and this is swarm, and this is the solution um, built by Docker, replaced to Compose, and auto load balancing, auto healing, and auto scaling. SCALING. Auto scaling. So that was really a fantastic thing. So this is the early era of the management or orchestration, and this is a little bit advanced era of orchestration. And then later on, people even like Google develop more fascinating stuff, which called in the world Kubernetes, which you called Kubernetes. In fact, now then comes into the picture the Kubernetes, which is really a fantastic discovery in this whole scenario. And this is very beautiful stuff here by the Google. So the Kubernetes, what Kubernetes does, it has more and more capabilities. It is open source. And even there are more stuff has been built on the top, which is more powerful and graphic user interface and easier. But let's do practical stuff. So this is the whole concept of the orchestration, Docker orchestration. That's how it look like, and that's how there is a need for the Docker orchestration. But let's now discuss number one, which is here really we discuss them one by one. So one, two, three. So right now, just discuss Docker Compose. I have written some stuff here. Let me shift it here and let me get it a little bit bigger so it's more visible and more efficient. Great. So install the Docker. It's very easy. You just install the Docker binaries and make them in executable. You can refer to the any source, right? I'm not going to right now show you that how you do that. But for example, here I have done an early experiment. So first thing first, you need a Docker file. For example, let me just get some files here. Great. Here is the compose file look like. First of all, you can go to this installation link. And up to this, actually, you have to this is the output file where your local binary. So there actually everything should live, right? And then you make it executable and you're good to go. So that's a very simple stuff for the Docker Compose. When you do this, you verify it by Docker Compose verify installation with help of Docker Compose and version. And then you should see something. That's how you do it. The step number one is that step number one, you create Docker Compose file. As you can see, let me just tell you what this. Every Docker Compose file must be starting with the parameter service, right? Service, and the indentation should be similar. If you use this as YAML file, this is YML. This is a .yaml file, and YAML file. Web is the name of the service number one. Any name you can create. This is service number two, and this is service number three. This service 1, 2, 3 is nothing but a container. 1, C1, C2, C3. This is just a container. And underneath you have image of container. You can pull this from the repository. Then there is port, which you want to make open or exposed. So you want to expose port number 80 here because Nginx run on the port number 80. Any volume you want to associate because you want to write this is the full path of your local directory and this is a remote directory. Remote means the container directory which you want to pack together or volume together. So these both are bidirectional as we have discussed in the previous tutorial. And then this is app. App, we need the Tomcat. Tomcat is nothing but a server to run the Java application, which runs on port 8080 and one database which we need is Redis. So this is kind of three container right now we needed to run our application, for example. What we do is we go here and I remove all the existing container. To do that, Docker PS, there are many containers are running. So I need to stop them one by one. So let me check. Do you see Docker PS A Q is the listing? Well, I can list all the container by Q. And for example, Docker do you see here Docker stop. And now what I can do is that I can write this one here and I can run Docker ps-q and it should be then popping all the container at once. And if I run Docker ps, no image is running. Docker psa, there are multiple container available. If I want to destroy all the container, again you must first stop the container before you destroy them. So I can remove the container with the similar, very similar. So only thing is that now they are not running because I need to write Docker PSA. And if I remove them, all the container Docker PSA, even after A, everything has gone, which is a great thing. So I have created here a tutorial as a folder. I can cd to that folder here. Now I'm into the folder. I can make it clear. LTR, there are some stuff already. So then I have created a new file, which is Docker Compose. And in the Compose, I have right similar thing I have shown you here. Now, before doing this, you can even create your custom image with the Docker file and Docker build image name. And whatever it is needed, you can interact with it. You can change it. We have seen in the previous tutorial that how you build the custom image. You can do that easily. And once you are done, you can specify that image here. Very easy peasy. It depends on your application and how you run your application, right? So everything depends on that. And after that, for example, right now we have this Docker Compose, and I can write Docker Compose, and then I can specify the file here, which is Docker. No, it is not Docker file. Rather, it is compose.yaml. Compose.yaml. And then I can say that please up is the command. For example, if I just write here Docker Compose, it's gonna show me all the commands here. So here are some options like F, E is this possible element project, profile name, and some variable, environmental variable I can specify. Environment path variable where my environment names are living. So here are the basic command I can do. I can do up here. I can do start, stop, scale here. I can remove, restart, push, pull here. And then these are all commands available to that. So, for example, docker dash compose, and then file is compose.yaml, and then I say that I want to up, and up means create and start the containers. Whatever written in the compose.yaml file, create all those containers and make them up and running. Please run them in detached mode. And that's in principle gonna create the duplicate of one container, but we can scale them later on. If I hit enter, then how easy it is. Docker ps, and you can see that over db app and these Docker Compose tutorial. It's always getting the name of the folder, and you're attached with service 1 and service. How beautifully it has created. It has mapped random ports with some port, because we have written the port is port for all these services. For both of our services, we have mentioned the port. Now let's say like that for some reason you need the redundancy, which we have discussed here, that you don't work with a single container, but you work with a multiple copies of the container, so that if something happened with one container, the second should be in place. To achieve the similar effect, for example, I need to scale up it to the 3 times or 4 times. How I can do this? I can really scale this up, and for SCAL scale, web is equal to 3 dash SCAL scale app is equal to 2, and SCAL scale db is equal to 2. Up in D. For example, I want to scale them in that fashion. Okay, what was the command again for scaling them up? First the app. Okay, first the up, and then this command should work. So for example, this up should be coming after this compose. Immediately after compose, we should give this command, because after docker file comes the file, and the argument means that part of the file, and then here we can if any other option, and then immediately comes the command, any one of the command. Okay, so for example, command is the up, and then we have since we have already used the first command to signify that we want to use a second command, we can use the scale here with the double dash. This is simple stuff in the Linux, I guess. But if we do that, how simple it is in Docker PS, as I haven't stopped the container right now, and it is taking care of everything by its own. And as you can see that I should have 3 Nginx, Nginx1, Nginx2, Nginx3. Beautiful. I have 3 server. I have 2 Redis, and I have 2 Tomcat. Beautiful. That's what I have required for. And maybe I can. What else we have here? Up, unpause task, run. Well, stop and remove the resources. You can also remove these resources somehow if you want. For example, any one of the container is stopped, then the service is still running. And that's how you achieve the Docker Compose. And if I here just simple mention nothing, but I just mention up and D, then it should scale them back to the Docker PS to one instance, because by default it's just reading the Docker Compose file and make you available one. That's why you need to mention how much scale you need it. Otherwise, it's creating a one copy. And if you really want to destroy whole services, then Docker Compose down is the Docker dash compose, and down is the keyboard. And any network associated with them is also gone. And now, for example, you have seen in the start of the tutorial in previous that I had to remove all the container one by one, and there I need to do the trick of $sign, and then I have used this trick to not remove the container. For example, if you have 20 container, you just copy paste the ID of each container one by one and supply the command remove. Here with down, I have achieved the same effect immediately. So yeah, that's how everything works here, and port mapping is already done. So the next tutorial, we are going to see that how we can make this solution better with Docker Swarm, because still, I mean, Docker Swarm is not very widely used in the industry, and we can say that only some industries are left, some old industries or some industries which are not very much bigger in the scale are still using Docker Swarm, but barely minimum or some very small organization might be using Docker Compose. But rather, other than that, there are not many organizations left using Docker Compose. But the fundamentals we must know, and we must know that why there was need of the other technology, and then more intuitively you understand this stuff. And I would admit that Docker Swarm is still used by at least 10 to 20% people in the industry, but most of the industry has been shifted to the Kubernetes developed by Google, or more advanced one. But Kubernetes is right now the big boss in the market, and you will see this requirement is must right now, and this is officially called container orchestration. Container orchestration, how you manage the container. Thank you very much for watching. Have a nice day. Bye. And we'll come up with the brand new tutorial, which is Kubernetes and very important, Docker Swarm and then Kubernetes. But next topic is Docker Swarm, and we'll see that how Docker Swarm would do the trick for auto balancing and auto scaling for you. And we'll also see this concept conceptually by drawing this as we do normally.